Good evening to everyone and welcome to the first speaker series event of the Center for Spatial Business in 2019-20. My name is Avijit Sarkar. I'm a faculty member in the School of Business and interim director of the Center for Spatial Business. I want to take a moment to quickly introduce the center to all of you. This center was founded within the School of Business at the University of Redlands in the summer of 2011. And it seeks to stimulate, support, and integrate spatial thinking throughout School of Business programs and expand research and scholarship in spatial business amongst faculty and students. First, I would like to take a moment to extend a warm greeting to everybody who is here tonight. I see a number of colleagues from the faculty, from the administration, colleagues from the the University Center for Spatial Studies, but most heartwarmingly, I see a number of students. And to all of you, especially all the students who are here, I want to extend a warm welcome on behalf of the School of Business. To all my colleagues in the faculty who have made tonight's event part of your curriculum, a number of you are in the room. I see Scott, Jessica, Kimberly. Thank you very, very much. Tonight's event is being streamed live for the benefit of those who couldn't be here in person tonight. And so in addition to extending a warm welcome to all of you, I would like to welcome the virtual audience as well. Before I introduce our speaker tonight, I would like to acknowledge a number of individuals who are on the staff in the School of Business. They seem to have disappeared at the right, oh, maybe not. Well, allow me to first acknowledge and thank two truly outstanding colleagues, Mary Dupree, she has recently transitioned out, and Charlotte Roth, who were key in putting together all the preparations for tonight. Assisting Mary and Charlotte have been Julia Easley. You can see her at the back. Nadine Davidson, familiar face, and the center's new graduate assistant and MBA student, Simi Ogunlei, who is there. And last but not the least, my thanks go out to our colleagues in IT services who have been providing all kinds of support, IT support for today's event. So without further ado, it is now my true pleasure to introduce our speaker, Dr. Piotr Jankowski. Dr. Jankowski is Professor of Geographic Information Science and Chair of the Geography Department at San Diego State. His research focuses on models and methods of spatial decision support, participatory GIS approaches to planning and decision making, and sensitivity analysis in space-time models. He has co-authored books on spatial decision support systems and on group decision making, and his work has been published in over 100 peer-reviewed journals. He has researched and taught in a number of places, including Austria, Brazil, Germany, Ireland, Italy, New Zealand, and Poland. Dr. Jankowski holds a PhD in geography from the University of Washington, and recently he was recipient of the 2018-2019 San Diego State University Alumni Distinguished Faculty Award. Please join me in welcoming Dr. Jankowski to the podium.
Thank you, Abjit. Can you hear me? Okay, right. Well, thank you very much for this very auspicious introduction. I feel humbled. I'd like to thank also Jim Peak, who is not here tonight, but Jim invited me to be a speaker, and I'd like to acknowledge him as well. So before I really get into the subject of my talk on geoprivacy attitudes, I wanted to tell you a little story, which is a true story. It's a story of mistaken geolocation. I will start by pointing to a place that is very close to, well, relatively speaking, close to the geographical center of the US. Taylor Farm in a little town, Patwin, Kansas. It's a 360-acre piece of land. It's very idyllic. You have a pasture, you have an orchard, you have 2 barns, you have a 2-story house. It's a kind of a place where you like to go if you wanted to get away from it all. This place, surprisingly, has been afflicted by all kinds of trouble. And to understand the reason behind it, let me take you a little bit into a technical realm of IP addresses. Internet Protocol Address. It's an obscure 11-digit number that your laptop, your computer, any device, your cell phone has as long as you connect it to the internet. It's very useful for the network to recognize that device and to facilitate these connected devices exchanging data packets, talking to each other. The Taylor Farm was, over the last 14 years, visited by US federal marshals, by IRS tax collectors, by the police looking for children who escaped from their families. Surprisingly, they all looked for them at that obscure location. And here's why. In 2002, a Massachusetts-based company called MaxMind, you can look them up right now, maxmind.com, offered a service to various other businesses, other companies, and the nature of the service was geolocation of customers by an IP address. So what they offered, beginning in 2002, they offered an ability to find where an owner of a computer or any connected device is in a geographical space. Mapping an IP address to a specific geographical location is not an exact science. At the best, you can locate a device and by extension a user of that device with the precision to a house, so to a specific street address. At the worst, you can only figure out a country where that device is located. The company, MaxMind, realized quickly on that there were a lot of these IP addresses that were very difficult to locate. Even today, when you go on the website of that company, they will claim that they can locate 99.8% of IP addresses to a specific country. But when it comes to a smaller region, like a state, they claim they can locate about 90% with the precision to a state, and then dropping down to a city, it comes down to 86, but they say 86% within a radius of 50 miles. That's a pretty large area when you think about it. How do they do this? Well, they can do it in a variety of ways. They can, for example, send a fleet of cars like Google has done over many, many years, and these cars will drive around roaming the streets, listening for open Wi-Fi networks. And when they find an Wi-Fi network, then they can record a physical address of a location where they picked up a signal of that Wi-Fi network. And based on that, they can infer, they can find other IP addresses. Well, they can also use the apps installed on smartphones. As soon as someone acquires a smartphone and that phone connects to the internet and opens GPS, through that app, they can figure out location at which that phone took on that IP address. And of course, they will imply or they will presume that that might be location of a device and the user of the device. So there are various ways to do this, but again, the precision is not guaranteed. And so the company, MaxMind, to deal with these problems of IP addresses that couldn't be mapped to exact location, they decided to go with default locations. And they set defaults for the country, for states, and for the cities in the US. Well, for the country, guess what? They picked as the default the location of geographical center of the US, which is in northern Kansas, pretty close to the border with Nebraska. For those of you who are geography buffs, you may remember the coordinates. Perhaps I'm going to unwire myself, and I can probably project my voice good enough, and then we will avoid the problem. So go ahead and switch it off, okay? Oh, I see. Okay. Let's try something different. Sure, this is your touch, right?
Yeah.
Okay. Let me see here. Let's do it this way. Okay. All right, and let me do it
Yeah, but it's not
this way. Yeah.
Yeah,
So hopefully it's going to be better. Okay, fingers crossed. Apologize for this interruption. Right, back to the geographical center of the US. The coordinates of the geographical center are, to be exact, if I remember, 39 degrees and 50 seconds of the latitude north, and 98 degrees 35 seconds of the longitude west. Now, in digital coordinates, that is equivalent to a pretty ugly two numbers with a lot of digits following the decimal place. So the company MaxMind decided to simplify it somewhat by going with the coordinates of the center of 38 degrees latitude north and 97 degrees of longitude west, which in decimal coordinates is equal to 38 point and a bunch of zeros and minus 97 point zeros, which is exactly the location of a Taylor farm. Considering that there are 5,000 companies who are the customers of MaxMind, and there are about 600 million IP addresses which cannot be geolocated with higher precision than the center of the country, it's no wonder that among those 600 million addresses there have been many instances of spammers, fraudsters, computer thieves, even people with medical problems calling 911, who were then mapped based on the device that they called from or connected to the Taylor farm. And that explains why this farm has had so many problems over the last 14 years or so. Now the question is, could the residents of the farm do something really to protect themselves against this pretty profound violation of their privacy, being visited by federal marshals, IRS tax collectors? Give me a break. Well, probably not. The mistake was on the side of the company, but that raises a broader question of what are the attitudes of internet users to geoprivacy, and hence that's the subject of my talk. Before I get to geoprivacy, let me address the issue of geomasking, or the topic of geomasking. It's a technical means of protecting one's privacy, of preserving spatial information, such as location of your place where you live. And there are different ways that you can exercise geomasking. Probably not you as a person who has a physical address, but most likely those who produce data that involve your address. So let's take a quick review of these techniques of geomasking. The simplest one is random perturbation. So assume that this point represents a location of an address that can be geocoded. Then we can assume certain distance threshold, and within that distance, the producer of the data, or someone who publishes the data, would perturbate that point at a random distance, where the distance is within the distance threshold. A slight extension of this approach would be a technique called donut masking, where you have two circles and two radii, the inner radius and the outer radius of this larger circle. And then, like in a donut, you would exclude from this area where you move your point the inner circle, and then the point is going to be moved at a random distance within that band that you get from subtracting the area of the inner circle from the area of the larger outer circle. Yet another geomasking technique called grid masking imposes a rectangular grid. So assume this is a network of geocoded addresses, places where people live. And then we can impose on that network a typical grid, and each point representing the address will be moved to the closest vertex of that grid, a point where two perpendicular lines of the grid intersect, like in this fashion. The whole idea behind these techniques is to obfuscate, to change the location of the original address, but to preserve pattern of the data, so that the data can be still useful in terms of analysis. You can infer some information based on the distribution of the addresses. Yet another technique, Voronoi masking, again, takes from original location of the addresses and then uses them as centroid of Voronoi polygons. A Voronoi polygon, it's a type of a polygon that has one distinctive property, namely that if you take a segment of a boundary of that polygon that separates or that acts as a boundary between two adjacent polygons and take the distance between two points that are closest to this boundary, this point will be equidistant to that boundary, meaning the distance from that point to that segment is the same as the distance from this point to that segment that separates the two. Similarly to grid masking, then the points in Voronoi masking will be moved to each point to its closest boundary segment. And again, when I go back and forth, you can see that location changed. Of course it changed, but the pattern, more or less, has been preserved. That takes me then to the main subject of the talk, geoprivacy. So we can use methods of geo-obfuscation to exercise geoprivacy. Clearly, we can. But do really people do it? What's the knowledge of this among general population of users? Geoprivacy can be defined as the right of individuals to assert privacy of their information. But there are various technical means that can be exercised to do this. And the question that I and my colleagues have been interested in has been how wide this exercise of geoprivacy is spread among the users, in particular internet users in California. So we asked two simple questions. How prevalent is location masking behavior demonstrated by internet users? And if so, what are the correlates of that location masking behavior? What are the variables that could explain it if it indeed exists? So we designed a survey. we targeted in the survey residents of the state who are internet users 18 years and older. There are many reasons why one would look at California other than the place where I happen to live. Number one, the state of California has one of the larger penetration rates of internet in the nation. Also, residents of the state are constitutionally guaranteed right to privacy based on 2016 California Electronic Protection Act. We acquired 2 samples of respondents. One sample, address-based sample, that's in survey research golden standard, because if you go of a list of addresses representing all members of the population, that would mean that we had a list, which we did, of addresses of all households in the state of California. You can then draw at random a sample that is a representative sample of the general population. And that's always a golden standard for any statistical inference. So we drew a sample of 2,300 households. They were contacted by mail with typical follow-ups, and we offer a small incentive, a $10 Amazon gift card. In parallel to this, we drew a second sample, open online sample. Sometimes that type of a sample is called an opportunistic sample. A researcher doesn't have any control of who is in that sample. Once you make it open on the internet, anybody who is interested can respond. You cannot stratify by geographical area to ensure more or less equal representation. So it's all pretty much at the mercy of the process that you launched. And we offered also a smaller incentive. The reason why we offered a smaller incentive was that we didn't know at the beginning of this study how many people would respond, and clearly we had a budget. We didn't want to blow that budget. If for some unforeseen reason we had thousands of respondents, our budget might be compromised. In constructing our survey, we were very mindful of avoiding a phenomenon called a social desirability bias. What is it? Well, briefly, if you ask in a survey right from the get-go that this is about privacy and practices of asserting one's privacy among internet users, you know, the red lights go off in the heads of your respondents. They all want to give you a favorable response towards privacy. We wanted to avoid that. We didn't want to bias our survey by advertising in bold letters that this is about privacy. So we mentioned at the beginning that this was about practices of navigating internet, and then as respondents went on, we led them onto the true thing. We also wanted to elicit from our respondents early on in the survey what their geomasking or geoprivacy protection practices were, and those were the leading questions from the get-go. Now, in conceptualizing the survey, we had the following model in mind. So a typical background variable that one would want to ask were followed by the so-called intervening variables, which derived from various experiences people might have acquired while being internet users. And those included bad experiences, privacy infringement, someone's identity being stolen, someone getting hacked. Given that we have a lot of data workers in the state of California, that also included data industry experience, which might have been this intervening factor. And also, we stratified our respondents among 2 categories: those who do enjoy social media and are very active on social media, and those who do not. that led us to these two one attitude and one knowledge-based variables, supportive geoprivacy attitudes and knowledge of geoprivacy that might explain what we observed in terms of location masking behavior. Now, how did we observe it, and what did we observe? At the beginning of the survey, the respondents were asked to provide their address. So they could do this in a very standard way by filling this form with the street address, and they had a full choice of only telling us name of a street or giving us full street address with the number of a house and even number of an apartment. Of course, city, state, and zip code. The geocoder working behind the scenes of that survey geocoded it very quickly, and the respondent was able then to see a pin corresponding to the address that one provided. Now, in addition to this information, the respondent had ability to manipulate that pin. So this gave us a very direct way of finding out whether or not someone practiced geoprivacy in an active way, which would be giving us an incomplete address, giving us a false address, or then moving that pin to obfuscate the address. And then we asked about these practices. So these were questions in which using a 5-point Likert scale, so this is ordinal data, right? We asked about their geoprivacy practices. We analyzed the data using non-parametric tests, so to analyze the differences between the two samples, the address-based sample and the open internet sample, we used Mann-Whitney U-test, which is a commonly used non-parametric test for checking for differences between categorical variables, two categorical variables. And these essentially were ordinal scale variables, and Mann-Whitney U-test is also good for that. We tested for correlation between variables using Spearman's raw statistic, not the Pearson, which would be adequate for ratio scale data, but for the data, the ordinal scale, of course, Spearman's raw was the appropriate measure. We also tested for clustering or lack thereof pattern using point statistic, global and local Moran's I. And finally, we looked for significant predictors of these different location masking behavior through an ordinal logistic regression model. This is the distribution of respondents in two samples. On the left, random sample. On the right, open internet sample. They look, at the first glance, alike, but when you take a closer look at them, you see some differences. One in the Bay Area, there's higher concentration of respondents in the random sample in the Bay Area and the Sacramento area than in the open sample. There's a better representation of respondents in the Valley among respondents from the open sample than among the respondents from the random sample. And in the area where we live, there are some differences as well, especially few more people from your area, San Bernardino, in the open sample than in the random sample. Quick look at the kernel density maps with the same data obviate what I said. Higher concentration in the random sample in the Bay Area and Sacramento than in the open sample. On the flip side, higher concentration in the Valley among respondents in the open than in the random sample. Now, in terms of the results, well, first let's talk about the differences between these two samples, statistical differences. I'm focusing on the significantly on statistically significant differences. So, briefly, online open sample was more female than random sample. Random sample was more educated than online sample, measured by college education degree. Random sample was older than online sample, and it was more affluent than online sample. It was more urban than online sample, but this difference was insignificant. Looking at the differences in geoprivacy behaviors. So these three groups of columns represent three different behaviors that we directly measured in the survey. One is the provision of limited precision of home address, so giving us incomplete home address, for example. The other one is intentionally provided incorrect address. And then third one is actively obfuscating the address by moving that point marker with the address. There is a clear difference between the two groups, two samples, in terms of providing limited precision home address. Many more percentage-wise respondents in the open sample did that than in the random sample. There's much less differences between the samples when looking at two other behaviors, intentionally providing incorrect address and moving that point marker around about the map. And these are much smaller percentages. Now, we also asked our respondents for other practices that can be classified as geoprivacy practices, such as giving incorrect address to retailers when responding to incentives online. A lot of respondents in the open sample, well, close to 35, said that they sometimes or often provide incorrect address. A little bit fewer, but still respectable, more than 25% in the random sample did that. Another practice is using various technological means to hide one's IP address. Probably the best known is the onion technology. Let me ask, who of you uses Tor browser? Nobody. That's interesting. Tor browser, it's an open source project, uses onion technology. Let me briefly explain how onion technology works. So if I want to browse a website, but I don't want to be identified by my IP address, and by extension who I am and where I do that browsing from, I would then open the Tor browser up. Let me backtrack. Onion technology, because I didn't say that, basically, by an analogy to an onion, has these multiple peels, like multiple rings. So I start my browsing, and I connect with a server somewhere. And that's the most other ring of an onion. That server connects to yet another server that's more inner ring of an onion, which in turn connects to the third server. Now, given that these servers usually will be located in 3 different countries in the world, the IP address that the website gets is not my IP address, it's not even the IP address of the first server that I connected with, but it's the IP address of the last server. So there's no way that, or it's very difficult, let's say. I shouldn't say no way. It's very difficult for that website to track me, my IP address. So that's one of the common practices of hiding one's IP address if you want to stay anonymous. Surprisingly, maybe not so, quite a high percentage of the respondents in the open sample told us that they sometimes use the IP alteration means, technology, to browse anonymously, and much fewer respondents in the random sample stated that they do. Another practice is to sometimes, or always, keep your location services, GPS on your smartphone off. More than 25% in both samples said that they do this. And at this time, at the time of responding to the survey, a good 20% in both samples did. Now going for a moment to our conceptual model in which we had the intervening variables divided into geoprivacy knowledge and geoprivacy attitudes. I also distinguish here general privacy attitudes from geoprivacy. These were the percentages of people who told us that they knew, for example, that GPS was not the only way location can be collected via a smartphone. There was about 50% who knew about that. Much more, 73% knew that IP address potentially reveals location, with a caveat that this is not an exact science. About 48% believe that they were well informed about how location can be shared once acquired. The trust in websites doing a good job of protecting one's personal data was rather low, only 34%. There was much higher percentage of those who supported anonymous internet browsing. Only 44% supported GPS devices in all motor vehicles, and only 8% supported the right of companies to collect irrelevant location data. So all in all, there were mixed results in terms of privacy and geoprivacy attitudes, and fairly high, although not as high as we expected for the GPS knowledge of how geoprivacy works. Now, in terms of spatial distribution of responses or practices, geoprivacy practices in two samples, this is a map representing results of local Moran's I statistic, which is a measure of spatial autocorrelation, meaning how close or how similar are, in our case, responses in geographical space. And that divides the responses into two groups, two clusters. Red represents locations of responses where people had favorable response, high. And blue represents concentration areas of responses of unfavorable responses, low, meaning low, there were a lot of similar type of responses. So in terms of this question about website doing a good job in protecting one's personal data, people who thought so, that the websites did a good job, were located in these three different areas, so in the valley and on the coast. And people in the Bay Area predominantly thought that websites did not do a good job of protecting one's privacy. In terms of supporting GPS devices in motor vehicles, there was very little support for this in the Sacramento area, and surprisingly quite a bit more in San Bruno. In terms of use of technology to alter or hide one's IP address, so one's location, quite a few people in the area around Santa Rosa did that, whereas much smaller numbers did that in places in the valley. Looking at the correlations, let's first, because this is a pretty busy table, let me spend some time describing what you're looking at. So in the columns, you're looking at the practice of providing one's address with good precision. That would mean those who provided us with the full address and did that truthfully. The next practice is the practice of intentionally providing incorrect home address, and finally the practice of moving that pin with the location of the address. In rows, you have various background and intervening variables. For the background, we only here look at two samples. The number one, that's the random sample. Number two, that's the open internet sample. So there is a inverse these are also, by the way, significant correlations. They are low, but they are significant. There is an inverse correlation between providing truthful address with high precision and being in open sample. So those who were in open sample, respondents from the open sample, tended to provide less precise home address than those who were in the random sample. Now, in terms of the intervening variables, those who enjoy, there's also a negative correlation between enjoyment of social media and intentionally providing incorrect address, which should be interpreted that those who did not enjoy social media were much more likely to give us an incorrect home address than those who did enjoy social media. In terms of having previous negative experiences with the infringement of privacy, such as hacking, theft of identity, there's also an inverse correlation. Those who did have those experiences tended to provide less precise address than those who did not, to be expected. In terms of knowledge that GPS is not the only practice, the only technical means of collecting one's location, there's a positive correlation, meaning those who did believe that this was the only way, GPS was the only way, tended to be more truthful and provide higher precision address than those who did not, who knew that GPS was not the only way. Those respondents were more likely to provide less precise address. The same is for those who believe that websites do a good job of protecting personal data, similar behavior. Now, there's an inverse correlation between those who used, told us that they used IP alteration technologies and providing high precision address. And then skipping to the very last here, this is the highest correlation that we found, statistically significant, between two practices. On the one hand, there is a practice of intentionally providing incorrect home address, and then on top of that, practice of moving PIN. Seems that people who do practice actively geoprivacy, they do it in various ways, not in one way. We also ran the ordinal regression, logistic regression model to look at statistically significant variables that would explain these observed geoprivacy behaviors. And so, again, the asterisk indicate statistically significant variable in the regression model, and those are, granted, we are testing the explanatory power of the model for the dependent variable, which is providing address, limited precision home location, limited precision home address. So one of these geoprivacy practices. It is, so that practice is explained by online sample, open sample. It is explained statistically significantly by knowledge that websites do not do a good job of protecting personal data, and by the practice of providing retailers with incorrect locational information. The other practice of using technology to hide one's IP address is explained by sex. Males tended to engage more in this practice than females. By belonging to an open sample, knowing that it is possible for IP address to reveal location, and also not trusting too much in websites and their ability to protect one's privacy. So in conclusion, in terms of the findings of the survey, 15% of participants admitted to providing incorrect address. So that was a percentage of those who engaged in one of these active geoprivacy practices. not very high, but respectable. Location masking takes place across demographic lines. We cannot really pinpoint specific background variables that would explain the practice of location masking. The key attitude that we took away from the results of the survey was that websites, the recognition that websites don't do a good job of protecting one's personal data, 73% of respondents. Also, the precision of location that was given to us by respondents could be traced to the context, trust, and knowledge, much more so to these intervening variables than to the background variables. In sum, I would conclude that there is relatively little exercise of geoprivacy among the respondents to our survey, as we were able to find out. What are the steps for some extension of this research? One would be to apply this study, this analysis, to different areas. So outside of our state, one of the areas that may be interesting to look at is the general data protection regulation area, which is pretty much the entire European community. That's the pretty powerful Data Protection Act that was passed and adopted by the European Union last year. It would be interesting and illuminating to expand the number of respondents beyond what we were able to obtain in our two samples, to incorporate additional questions such as political views, which is not really captured by the demographic variables because it cuts across the demographics. Also to test for alternative motivations for masking behavior. One of them would be location spoofing to gain benefits. So what's location spoofing? Well, essentially it's providing false information to get that coupon online, to get the reward that a retailer offers you. I'd like to acknowledge my collaborator on this study, Dr. Dara Seidel, and with that also the support of National Science Foundation that funded that study. And I'd like to thank you very much for listening to the talk, for your attention, and invite questions. Thank you. Please, yes. Two groups. Two groups of respondents. Yes, random sample group and open sample group. Right.
Sure. I was thinking about you categorize them into ones who gave incorrect home locations and ones who matched their home location.
No, we didn't look for that. Well, we looked at predominantly at three practices of hiding one's or of revealing one's location. So one was providing an incomplete home address, which would be just the name of the street where one lived. The other one would be to providing false address. This is scaling it up. So not even the street where one lives, but totally different street, maybe different city. And the third one was to move that pin about the map to a very different location. Yeah. Yes.
Can you say about onion program?
Onion, right? Technology, right?
Location?
Yeah.
Yeah. Now the program is no more available because now people know how to crack it. So now there is a physical onion router which changes your location every 3 seconds.
Well, the Tor is still available. You can download Tor browser.
No, I'm talking about onion.
Oh, okay, yeah.
So this is what we learned while our course of ethical hacking.
Mm-hmm.
But now the program doesn't work. Like
That's right, yes. You're absolutely correct. So those are routers and physical servers that are being tapped to, offered by volunteers, people who believe in this project, and those are people all over the world. Yeah, correct. Well, thanks for bringing it up. Yes.
I mean, it seems like there's an assumption that if anyone can ask an address and we would have to respond. Why would we have to do that?
You don't have to do this. You don't have to provide your address if asked for. You can opt out. You can object. It's more about passive provision of your address by way of simply browsing, opening web pages that whoever operates that website and offers that web page can trace you to your IP address, and it will assume that the location where this address is at is your physical location. And then based on that, this is how advertising pretty much works. If an advertiser knows your location, then that advertiser can quickly correlate your location with all bunch of geodemographic variables. Your census block group, your census block. And there's readily available data about people who inhabit that block. What is their median income? What are their spending habits? What do they enjoy? What are their hobbies? Where they shop? All of that is available. And that's how you get sometimes advertisements that you think, well, that's maybe even relevant to me. How do they know that? Well, that's how they know.
So I mean, think about it. I believe it was Mark Segoff many years ago looked at, are we citizens or are we consumers? I mean, it seems as though this definitely puts us totally in the consumer place, and there really is not a lot that we can do.
This particular use of locational information is about treating us as consumers, but there are other uses of that, which I didn't mention in the talk because they go outside the topic of the talk, such as citizen participation, public participation in various citizen initiatives, local planning, development, civic activities. This information has been used also for those which I guess you and I would agree more socially noble causes. Yes.
Did you get the same amount of responders for each survey, like the mail?
It was roughly the same, yes, roughly the same, yes, surprisingly so. Surprisingly so. Even though we expected that the online open sample would surpass by far the random sample. Yes?
Going back to your introduction where you brought up
Taylor Farm, yes.
Taylor Farms. So since 2002, do you know if anything has been done to try and mitigate the problem, the IP problem that they have?
No, truthfully, I did not really probe that deep enough onto the website of MaxMind to see what default coordinates they use as of now for the geographical center. That's something that I haven't done, but it would be interesting to do, really, to find out had they moved. Of course, it would take a little bit of effort on their part to find a location where no one lives. Although, in that part of Kansas, maybe not so difficult. Yes?
I was just wondering how much confidence you have that respondents understood some of the concepts like IP address or
That's a good question. Yes, we did not test for that understanding, level of understanding. We essentially assumed that if a respondent answered a question, one knew what this question was about. But it was an assumption, yes. But it's a good point. We did not really probe into their in-depth understanding of the subject of the question. Yes.
So you were talking about those who trust that the websites are keeping their privacy protected, and those who may be a little more skeptical towards that.
Yeah.
And so I was thinking about, in the terms of those who are more skeptical, would they even put more effort into masking it? Since let's say I'm a skeptical person who is putting information to websites now daily or very very frequently, and I don't feel that these websites are protecting my privacy. So is there any? I lose that kind of what's it called? That idea that they would, like in or that hope that they would. And so my question would be, does that cynicism of being able to go through that effort to mask that idea create some sort of pessimism for the public to actually even go forth with masking it, since they feel like, oh, that's pretty much a lost cause if I even go towards the effort to mask it?
That's a very good question, and we did not really test for this in the survey, whether or not this lack of trust in websites protecting one's data correlated with the diminishment, reduction of one's activities or even will or interest to contribute information or data to specific website or any website for that matter. We did not ask for that. That might be a good hypothesis to test. Yes.
What's the direction? Where is this headed? Do you see people taking more action to protect their privacy by engaging in these practices? Do you see the potential for legislation, such as in the UK, or any suits maybe being brought from the constitutionality of the privacy of these data being collected?
In terms of the legislative efforts, I haven't looked into developments that would be probably could be tracked by lawsuits brought on behalf of internet users, individuals, organizations in the state of California, because we have privacy protection law. It would be interesting to look into that. I haven't done this, so couldn't really substantively answer your question. Now, in terms of where is this heading, I would be much more confident to answer this question if I were able to repeat this study sometime down the road, and that would be really a good comparison. I can only speculate, but I hate to speculate. So I respectfully will not offer any insight because, again, I haven't done the follow-up study. Sure.
Please join me in thanking small token of appreciation for you. Thank you very much.
Well, thank you. Thank you very much. Thank you.
Well, first off, again, please join me in acknowledging and thanking our speaker one more time. To all of you again for coming and participating in the event today. Please accept my sincere thanks on behalf of the Center and the School of Business, particularly to all the students who are here tonight. There are other things that you could have spent your time on. Several of you are mandated to be here courtesy of your instructors. But if you weren't, kudos to you for showing up and learning about this important topic. By way of inviting you to the next set of events, let me take this opportunity to announce that our next speaker event is going to be on Tuesday, the 5th of November. And on that particular evening, it's again an evening event at the same venue, the Casa Loma Room. It would be our honor and our privilege to welcome from Esri, Jim Harries. Jim is a cartographer and a storyteller par excellence, and is also into policy mapping. So if your schedule allows and if your instructors happen to mandate you again, I would be delighted to welcome you back on that particular Tuesday. And the following Tuesday, which happens to be Tuesday, November 12th, the center will feature Dr. Lawrence Joseph. He is the Director of Location Strategy and Location Intelligence at KFC, which is part of Yum Brands. KFC, that's right, fried chicken. And he's coming in here all the way from Kentucky, and he's going to discuss his work in the area of massive mobile data in determining KFC's location strategy. That second talk happens to be on the eve of GIS Day, or part of Geo Awareness Week, which is a major event on our campus. So please mark your calendars for Tuesdays, November 5th and November 12th. And again, sincere thank you to all of you for being here tonight. I know if you have to head to class, have a wonderful rest of your classes. To my faculty colleagues, thank you very much. And there's still some dessert and coffee. Please feel free to mingle and network. And I hope to see you next time. Thank you.